So again, yeah, hope everyone's having a lovely Wednesday morning or afternoon or evening, wherever you are. Today I want to talk to you guys about skeleton modeling in HyperMesh. This is a relatively new workflow or ribbon that we've added into HyperMesh a few years ago in version 22. So it's still somewhat new, and it's been mostly designed from the ground up for mostly for the automotive industry, but I do think it has some potential use cases for aerospace. But I at least want to give you guys some exposure to this workflow so that we can, yeah, at least see, and start thinking about how can we expand this workflow to be more viable for aerospace users. So yeah, the demonstration will probably be a little bit short today, but definitely I encourage you guys to drop any questions in the chat. We can have a little bit of an open conversation about this tool. So if you have like kind of comments or suggestions, again, or questions about how the workflow is working, just drop that in the chat. Okay. So yeah, first of all, getting into skeleton modeling a little bit. So what this is really a workflow for creating reduced order models from some source, either CAD geometry, finite element topology, voxel topology, or even interpretations of some topology optimization, right? So this could be for you guys, for example, you could run like if I show here, I think this demonstrates this well. So like maybe you could run a topology optimization on some airframe, some fuselage, and then this workflow I think would be good for like extracting these stiffeners basically, a little more a little more automatically. So the approach I'll show is a little more manual, but I think the future of this tool is to, for example, take some topology optimization results like this on a fuselage and then generate, 1D stiffeners from those seamlessly. So yeah, right now, it's mostly geared towards recognizing automotive-based components. So the automatic detection, I think, isn't quite there for aerospace yet. Um, but yeah, generally we have this workflow that'll detect all of the members, and then you can say, all right, where are your joints going to be? So where are your members going to be connected? And then you would connect all of those joints by members and connect those members through panels, right? So like in an aerospace context, your joints might be your connection points between your stiffeners. Your members might represent your stiffeners, and your panels might represent, like the OML skin, for example. Um, and yeah, looks like someone's having trouble with audio in the chat. Is anyone else having trouble hearing me? Okay. Okay. Yes, some of us can hear me. So I would say, yeah, check your audio source if you can. Um, okay. So yeah, that's how I think this overall process could work for aerospace. Um, I don't think I don't think it makes any sense for wings, but I think it can make sense for fuselages. So again, mainly creating these reduced order models, basically generating these 1D members and sections connected by 2D panels from some more detailed source. So this could just be if you're just trying to create a more data friendly or just like a more reduced order model just for model building purposes, or this could be for maybe optimization purposes, concept level optimization purposes. And so, maybe you want to set up parameter optimization on the sections that you create here with the 1D members. So a few different use cases, maybe just model building or for concept level optimization, either would work. So yeah, I'll show you guys kind of a process on a fuselage of how this might work. Again, more manually, but just to show you guys sort of give you guys the idea of the workflow and hopefully give you some ideas of how we can improve it to make it better. Okay. Oh, I lost my, give me 1 second. I lost my chat. Let me pull that back up. Okay. All right. Got the chat up. Okay, so in HyperMesh again, in any version after 22, you'll see this skeleton ribbon over here. And then it'll give us our option over here to create or to open up a skeleton ribbon, which will have all of our entities relevant to skeleton modeling. So it would have our joints, members, and any panels that we create. So some of those options for automatically generating this reduced order model are under this auto generate category. So the categorize and the auto lines generally, again, right now are built off of recognizing automotive based components. So if you look into categorize, we go into our options. It's looking for, certain holes, hard points, glazings, castings, panels. Um, in my opinion, this doesn't really translate as well over to aerospace. So I do think we have some work to do here. And if you have some suggestions of like certain aerospace components that we could pick up within a fuselage, like GFM or maybe even a more detailed model, let us know. And then the extract lines would, of course, like in this case, it would extract lines representing these members. But in this case, I'll show you guys the more manual approach. So I have this model. This is like an STL model. If you look, I got triangles all over here. Again, this source um, can be elements. It can be geometry. It can be some voxel mesh. But yeah, so again, going through, we would create some joints, members, and then panels. So with the joint box, I can create joints. And again, the idea would be that this step would be more automatic. But in this case, just showing you guys kind of what the manual approach looks like. So basically what I'm doing here is I'm creating a box that would define out the legs of my members. So I'm gonna decrease this. I forget how. I believe I can adjust, like select the face. I forget how. So I'll just do click on that box and then I'll do 100, 100, 100. But basically what it'll do is it'll create these section cuts at the ends or at the faces of this box based on what the box is capturing, right? So right now the box is capturing these members, but it's also capturing, looks like this portion of the skin here. So what I can do is exclude the component for the OML, that OML skin, so that it doesn't get considered whenever I'm making my section here. So now based on this box size, and I could try reducing it a little bit more if I wanted, but now basically what it'll do is it'll create these C-beam cross-section cuts here that it gets connected to at this joint, or that get connected to each other at this joint. And I can decide my element size over here or my element density. I'll just use my default, hit play, and you'll see it'll create these 1D elements and it'll visualize the section cut, or basically the cross section that it generates from those section cuts on the ends of the box. So yeah, I can basically just follow that process, kind of go through, create my joints. I can also go into here and edit some of the dimensions. I think I want to do 100, 100. There we go. And then let's see, let me reselect. Okay, that looks good. And then in cases like this, where like the box doesn't really line up normal to the joint that well, you can just move it, basically. So if we come over, come over here, move joint box, we can rotate the joint box to be just a little more, maybe this way, a little more normal with that junction. and then escape, escape. So that'll probably give us a little bit of a better section. And again, I can also exclude that skin that it was picking up and then play. So again, and yeah, in that case, I would probably want to adjust or align that. So like what I can do is maybe come over here. Give to this one as well. And escape, escape. And then we'll create our joint. Okay. And I'm going to keep going for now, but what I can do in cases like this where I don't really like the alignment of these joints is I can use this over here, this little assign, or no, excuse me, which one is it? Do I want? Align, this one. Align joints to an anchor. So this, in this case, I could like align this joint to this joint or something like that. But yeah, for now, let's continue on. So again, the idea would be that this would be more automatic. But now that we've created these joints with these C-beams being connected here at the junctions, I can create members in between them. Boop. Boop. And then what it'll do is it'll go through and I can decide how many cuts, how many section cuts I want to do, you know, like through, again, this can be either through some source CAD or some finite elements. So this is just saying how many cuts do I want to cut through to create those sections. And again, we can exclude any unwanted elements from the skin that it may be picking up. So basically it's going through, it's creating 3 evenly spaced cuts. And now I can create C-beams with an element size of 40. Again, I can also define how many C-beams I can create in between each cut as well. So whichever the preference is. And then, yeah, that should be all I need to define there. So then I can just go through and just start cutting up and defining my members in between my joints. And I can also, you know, move around these cut planes as well if I don't like kind of where it's defining a cut. So you can adjust all of these things. So this is where, in my opinion, I think there can be some use for aerospace users, just this ability to kind of create these cuts through maybe some complicated or more curved geometry than what I have here. So again, anytime it like picks up those unwanted like areas of your model, you can just exclude those areas, or you can also just like adjust the size of these by just clicking on them, and you can just adjust the size and escape. So yeah, some of these like it's picking up some of these members which I wouldn't want, but for now I'll keep going. So in that case, you would want to like exclude some of those. And then section cut. And so you see, like I mentioned early on, it's in the skeleton browser, sort of populating out each of our joints and our members. Okay, so yeah, I've created a few joints connected by members. What I can do is now maybe isolate those. And then we see, so this is basically our reduced order model here. And then now for our final step, we can connect these members via a panel connected through C bushes. So if we open up our panel, go into our settings, this will give us kind of similar to when we were creating members, right? It's or joints, giving us our options for creating or defining element size. In this case, of course, we can define our element type. For us, this will be quads. And then you can define how the connection gets made between the panels and the members. So generally, it'll create it'll create C bushes that you can define the K values for here. Okay, so I can just grab all of my members and then apply. We'll give it a second and it'll create our little panel mesh in the middle. And then from there, like I think the fuselage had a hole here. So then if I wanted to cut that hole in, this is a little bit of a separate tip, but then I can come in and just cut a hole somewhere into that panel. But yeah, that basically covers most of what I wanted to show with skeleton modeling. There's a few other aspects to this. You can, of course, create a symmetry plane and project these entities across some plane of symmetry. And yeah, again, the idea is to enhance the tool to make it more easily or better recognize um, fuselage stiffeners, for example. That's where I see the use case. Again, I don't particularly see a benefit for using this for creating reduced order models of wings. Um, if you're interested in doing concept level optimization of wings, you can look into creating a design space out of the wing and then just running like a topology optimization on that design space. So if that's something that interests you guys, like concept level wing optimization, let me know. But yeah, a little bit of a shorter demo. I'll open up the floor to any questions because, like I said, I think this is a little bit more of a a little bit more new to aerospace. I'm curious if anyone like has any thoughts or any ideas of how we can improve the tool for aerospace users.